All right, so this is number 5. They give you this table with all of the values that you're gonna need, first and second derivatives. So letter A, it says, here's H, find H prime of 7. If nothing else, it's at least straightforward, right? Find the derivative, plug in 7. At least you don't read it and go, what on earth is it asking? All right, what rule is this one? It's chain rule. So how do you write out your chain rule? Good. Perfect. That's a point. Give yourself a point for knowing the chain rules. And then the other point comes from plugging in 7. Now this first part's tough. You're going to do G of 7, and whatever number that is, you're going to do F prime of that number, okay? And then you'll plug 7 into this one as well. So G of 7 is 0. F prime of 0 is 3/2. That first part is 3/2. And then G prime of 7 is 8. You get a point for that. If you multiplied those together, why did you do that? Don't do that. Don't do that. If you accidentally did it wrong, it's wrong. All right. Letter B. Let K be a differentiable function such that, oh, they don't give you K, they give you K prime. Is the graph of K concave up, concave down, or neither? Which derivative tells you about concavity? Second derivative. But it's nice because they already gave you the first derivative. So you only have to take the derivative once instead of twice. Now I heard you guys talking about this. Which rules do you need? Yeah, product and chain. Okay, so it is the first thing, which will look like this. Derivative of the second plus the second thing, which is G of X. Now here's where the chain rule comes in. You bring down the 2, it's going to drop to a 1. I put the 1 in there because that's what throws people off. Like, I almost wish it was a bigger number. Like, if it was a 7 and you brought it down, this would change to a 6, you know? And then what are you gonna also multiply on there? Yeah, that's the chain rule, F prime of X. You get a point for doing that, which I feel like that should have been worth 2. Whatever. And then what are we plugging into this? 4. All right, buckle up. Here we go. What's F of 4? You guys find it on the table. F of 4. So 4 squared is 16. Good. G prime of 4, 2. G of 4 is -3. And then we've got that 2 in there. F of 4 is 4. And then F prime of 4 is 3. Don't actually work that out. All you need to know is whether that result is positive or negative. This would just be 32, and then this is all going to be negative more than 32. Do you get what I'm saying? So the overall result is what? Negative. Oh, and you get a point for that too. So then you're going to write a sentence. Your sentence needs to start. It was this M, K. K of X, where did I get M? Oh, from that milk problem we were doing. Your sentence is going to start K of X is or K of X has. So K of X is concave down. Good, perfect. At X equals 4 because K prime prime of 4 is negative. Or you could have said K of X is negative there. You just have to indicate at that point. And then it was a point for that explanation. Listening to you guys, it sounded like that went really well. Good. Yeah, that's fine. In fact, yeah, if you put the 4 and the there, you were like extra on top of it. All right, now we're getting into integrals here. So what is C? Oh, this is where I got M from. They called this one M. Let M be that function, then accumulation part in there. Find M of 2. You're not doing a derivative, you're not doing an integral, you're just going to plug in 2. You can leave this as 5 times 2 cubed. If you figured that out, what is that, 40? But that's fine. You can just leave it like that. And then we're going to have plus integral 0 to 2 f prime of t dt. I just plugged in 2 for x. This is your fundamental theorem of calculus. Fundamental theorem. If you have an integral of a derivative, that takes you back. So it would just be f of x such that 0 to 2. That's your fundamental theorem of calculus. And then you're going to do upper boundary minus lower boundary, and you're going to get those from the table. So what's f of 2 from the table? 7. And then minus f of 0 is 10. That whole thing was just 1 point, which again, I think it should have been 2, but you know, it is what it is. Because I feel like if you got this, it should have been a point, and then evaluating it should have been a point. Because say you messed up and wrote the wrong number there, but you had this right, you knew the calculus, you just read the table wrong, and then you wouldn't get it, you know? All right, letter D. Is that function, the one we just looked at, increasing, decreasing, or neither at 2? Now, for increasing and decreasing, you need to find what a derivative. All right, so we're going to find m prime. We're going to plug in. What do they want us to plug in? 2. We're going to see if it's positive or negative. So what is your derivative? We've been doing antiderivatives for so long. You got to switch gears. Derivative of 5x cubed. Good, nice job. Plus, now the derivative of the integral, they cancel out, and it is just the stuff inside.